Hi everyone, this is Amir Mohammad Shahsavarani. I'm happy to have you by my side in the course of algorithm in computer programming. Let's continue our progress in session 2, and we are still in our theoretical issues. Hope to finish up it soon and get to the codes. Good. In this session, we want to review some history of coding, programming, computer issues in the domain of algorithm and algorithm uses in the computer science and computer programming. Okay, sorry. Let's start with from early computer ages and early computing and algorithmic beginning. We want to delve into the rich tapestry of algorithmic history, and we want to uncover the fascinating story of how computational concepts evolve over time. I think, in my opinion, from ancient civilizations to modern computing issues, algorithms have played a crucial role in shaping our digital world. So, first, we can mention Leibniz stepped reckoner. Uh, as you can see in the picture, this was stepped reckoner of Leibniz. Gottfried Wilhelm Leibniz, his full name, a German philosopher and mathematician, invented the first mechanical calculator. This innovation sparked interest in calculating machines and, um, telling you the truth, literally, it laid the foundation of algorithmic thinking. The next one we can say Charles Babbage's analytical engine. As you can see, the man standing by the engine, and Charles Babbage was English inventor, conceptualized the analytical engine and proposed machine that could perform calculations using punch cards. Although this machine, as you can see, was not built by Carl's Babbage, but his idea of punch cards influenced later developments in computer science. And if you may have seen in museums, or maybe you remember it, we had many computers with these punch cards. The third pioneers in this era would be Lady Augusta Ada King, Countess of Lovelace. We can here searching Ada Lovelace. We have a language named Ada. I think, if I remember truly, it was a sort of military language. But Augusta the King, the full name of her was Countess of Lovelace. She is often considered the first computer programmer. You can search in the internet her notes, and her notes on the analytical engine included the what is considered to be first computer program. And as you can see, the table after his picture in the image I have put here. Okay, next issue we wanna discuss together the early years of computer science, which routing from 1890s till 1940s. First of all, we can say Hermann Hollerith punch card systems that have ideas from this system of ideas from Carl Babbage. Hermann Horowitz developed a punch card system for tabulating statistics, which became a crucial component in the early development of computing. Then another German pioneer scientist in computer was Konrad Zuse or Konrad Zuse. He made many computers. Z3, Z4 are the most famous one. Uh, Konrad Zuse was German engineer, built this first fully automatic digital computer using just binary coded algorithms to perform calculations. Binary means 0 or 1. Then we do have our new era's father of computer, Alan Turing. He made automatic computing engine, or short form ACE. British mathematician Alan Turing. Then he made this theoretical computer that laid the foundation for modern programming languages. Okay, then we shall go to the uh, step of downing of the programming languages. We can say starting of them. Colossus and ENIAC were two first languages. You can see Colossus here, Colossus, pardon, and ENIAC. You can see these ladies. You can see the lamps on the ENIAC. These were first processor units. Uh, these two, Colossus and ENIAC machines, may mark the beginning of electronic computers, with programmers using machine-specific codes to solve problems. Yes, we programmers, we developers were coming to the history now. Afterwards, we can say Fortran. Fortran computer did, I think it's for IBM, yes. Fortran was the first high-level programming language, which stands for FO for formula, FOR. Uh, TRAN, TRAN, was the second part, translating system. Fortran, formula translating system. So the Fortran was developed for scientific applications, and it has revolutionized algorithmic development. And in modern computing, we can say the beautiful and harsh language of C programming language, 1972, but Dennis Ritchie. This language, C programming language, become a cornerstone for modern programming, offering flexibility and efficiency. And as you know, it has been evolved through the time and evolutionized. Nowadays, this C programming we do have is much more different from the first version. Hmm? Okay, the next two modern computing systems were Lisp. As you can see, Lisp means list processing, and Prolog. Prolog means programming in logic. These two languages, between 1958 and 1960s, so first list processing, and then Prolog, programming in logic. These two languages were focusing on artificial intelligence, logic, and functional programming. So that was huge. That was wow. And we do have the 1980s till 1990s. Most of the scientists say that we do have a decade of evolution. First of all, we are seeing object-oriented programming, OOP, which would be Coming next to these tutorials, we would speak about object-oriented programming. Languages like C++ and Java popularized object-oriented programming concepts, enhancing algorithmic developments. And nowadays, most of the languages have these concepts um, incorporated in all of their concepts. You can see that, for example, C Sharp is a mixture of Java as Visual Basic and C++, has this object-oriented programming and many other languages. Then the second issue that is important for algorithms would be internet and web development, that if you are more than 35 years old, you would understand it fully. But if you are less than that, maybe you're born with the internet. I don't know. The World Wide Web, that we call it WWW, connection, uh, it was created and led to surge in web-based applications, algorithms, and programming languages, and many of uh, algorithms that we do have now are just born after internet and web development. And our last or maybe final part for this video is algorithmic innovations. First of all, we can say in the new millennium is big data and analytics. The exponential growth of data drove the need for these offensive algorithmic solutions, such as machine learning, such as deep learning, natural language processing, NLP, and much more than that. We can say the AI. What we do have here, most of the people just I don't want to emphasize on issue, but we can say Bing, for example, for Microsoft, the Copilot in Bing, or ChatGPT's version, or Llama for Meta, or we can say GP, GIPI, and many other more. These are all natural language processing systems. And the second step in 21st century of algorithms is cloud computing and parallel processing. Cloud computing and parallel processing enable distributed computing, which can allow algorithms to scale and adapt to complex tasks. What do you mean by cloud computing and parallel processing? Means that we do have our information in several uh, servers worldwide, and just using the internet, we connect them together. So for this session, I want to conclude. I can say that this journey through the history of algorithm development shows us computational concepts have evolved over time, like human evolutionary history, and this evolving throughout the time, influenced by pioneer innovators and technological advancements. As we look to the future, it's clear that these algorithms will continue to play a vital role in shaping our digital world. What's more, maybe some years later, these data would be some part of history, and even us, we maybe uh, become one part of history that future programmers, future computer software developers just read about us in books. In the next installments of this series, we will delve deeper into the specific type of algorithms, exploring their inner workings, applications, and implications. Just follow me and join me in this exciting adventure as we uncover secrets of algorithmic magic. Thank you again watching us. See you soon in our next video. Bye for now.